Hello, everyone. Good evening. I'm Jubril Issa. I'm a software developer at Andera, and my talk today will be focused on asynchronous programming in Python, how and when to use it. So before I go into my talk, I'll just start with a bit of a story. This happens to me some time ago. So once upon a time, about a few months ago, I was working on this project, and the first task they gave me was one of the tasks they gave me to do on that project was I'm supposed to make queries I'm supposed to make calls to an external API and then get data from that API, about 500,000 endpoints. That was one of the things I'm supposed to do. And then based on the results I get, do something with that. And yeah, my normal self running Python, one of the first things I did was I just jumped into the code base, jumped into my IDE, and I started. This is just like an extract of the logic I did then, which was, if you can see, I got all the endpoints, a list of endpoints, and then I was iterating through the endpoints. That for each of the endpoints, make a request to the endpoint, and for the response that you get, just do stuff with that. When I wrote the script, I was dealing with about 500,000 endpoints, and then I was iterating through those lists one at a time, making call to an external API, and this is a network call. And then once I get the response, I do stuff with that. And you won't believe what happened. I kept waiting for the script to finish. This happened. I don't have hair on my head now. I waited for the script so long, I grew so much hair like this on my hair. And then while waiting for the script, more things happened. I kept waiting for the script. And then while I keep waiting for the script, more bad things happened. And then please definitely don't ever be like this guy. Now let's say I do an analysis of that problem we have. If we look at that script I wrote earlier, we have, so I said 500,000 calls, and then I was iterating to this list, about 500,000, and then for each of them, I'm making a call, an external call, network call, to an API to get data. So now let's assume that for each of these network calls I'm making, it takes 1 second for the response to get back. So my math is very bad, so for those who can help me with math. So if we take 1 second for just one endpoint, it means in 1 minute, I would have just done 60. In 1 hour, I would have just done 3,600. You can just keep extrapolating. I think it will just take you days to actually run for 500,000 requests. So that is bad. And that was why that guy grew so old, and don't ever be like the guy. So now, if you are given such a challenge, what are you supposed to do? Which is one of the things I'll be talking about today. And then I'll be comparing some of the best things you could have done to avoid things like that. So first of all, let me just go straight towards, so the kind of code I wrote today, it's called synchronous programming. The program starts running from the top, it goes, iterates through the list, it picks one item in the list, tries to make a network call, it blocks, because that library itself, it has to wait for the response to get back from the API before it goes to the next line. That's doing stuff. So it blocks at that point. So that's the same way synchronous does. So like it will just keep going line by line. Each of those lines will be blocking the next line. So if there is anything, let's say I'm trying to insert to a database, or I'm waiting for response from the network, that line will just be there momentarily till the response get back. Could be maybe success of insertion into the database or successfully retrieving stuff from an API. So it's not a bad way to code. It's not bad, but you just have to know where and when to use something like that. So if you're dealing with network calls that you're dealing with such large data, that might not really be the best approach. So while asynchronous, on the other hand, it runs in an event group, And for this paradigm, what happens is, so if it hits a place that is going to block an operation, let's say in this other case, I'm making a call to an external API. It's a network call. So the program is just going to skip that part. It will be waiting. So it will go to the next line and keep running other parts of the code. So once the response comes back, an interrupt is being fired, and so the framework itself or whatever language you're using should be able to handle this and okay, picks the response from this and then continue. So you don't just wait. You don't keep waiting for the response to come back before you continue. That's just the idea of asynchronous and synchronous. I will now give us a real life scenario of something that we know very well. This is Lagos. Okay, this is Nigeria. Yeah, Nigeria, Lagos. So, of course, we buy fuels into our cars and all of that from time to time. So, if you look at when you want to buy fuel in your car, so when there's no scarcity, when there's no scarcity in the car, when there's no fuel scarcity in the country, what happens is you just go there. If an attendant would have to attend to you, they just fill in your tank and then you move. So the next person comes. So let's assume for each person, the attendant takes 3 minutes to fill the car, the tank of the customer. So it will take, let's say, 3 minutes. If there's no scarcity, no problem, it's fine, it's okay. But now when there is scarcity of fuel, we have like 500 people trying to buy fuel at the same time. And then one attendant is attending to the same people. So that's the same analogy I wanted to look at. So we have so many customers to attend to, and then this person can only attend to them one at a time. And it takes about 3 minutes to attend to one of them. So let's say you use 2 minutes to sell the fuel, and then it takes 1 minute to collect the fee. So that's 3 minutes. So if you also do this extrapolation, so if it takes 3 minutes to attend to one person, so it means in 1 minute, you will only be able to attend to like, I think 20 people. And then if you do that, if you extrapolate, you like, if it's only going to be able to attend to 20 people in 1 hour, then let's say 500 people come at the same time. That's around, I told you my math is bad. So, so that's like, so 20 people in an hour, so that's 25 hours. So that's more than 1 day. No wonder in Nigeria they don't used to attend to every people, and some people will even sleep over when there is scarcity. So, but let's now look at this same scenario I created in an asynchronous manner. Don't forget I said it takes 3 minutes to attend to one person. So 2 minutes to sell the fuel into the tank, and 1 minute to collect the money. So ideally, let's say in an asynchronous way, so like one person is attending to them, so you fuel in the tank for 2 minutes, and then while the person is still counting the money, you move to the next person. I know it's not ideal in Nigeria, you don't trust, you might not want to trust customer to count the money and give to you. But let's just say in an ideal scenario, you trust the customer that once you sell the fuel, he's going to give you the right price. So while he's still counting the money, you keep attending to the next person. So once you finish counting the money, it just gives you, so that time, so let's say it takes 1 minute to count the money. And it's after 1 minute, you are still filling this guy. You just take the money and pocket it. So it means you are just using 2 minutes for each of these guys. So it means in 1 minute, if you do the extrapolation. So if you look at all these same scenarios, that's the same way in code, asynchronous and synchronous work. So you're like, instead of you to just devote all the time for something that would take so much time, you just move to the next item, and then you keep attending. Once a response comes back, you just take it, and then you keep on moving. So with the same idea, just look at it that in code, if you have it in code also, that's also, so that's also the same way it's going to work. So if you look at the same analogy, 500 people, it will take 25 hours for synchronous process. If you do the extrapolation, for this same analogy I created, it will take about 16.6 hours to attend to 500 people. Now, we're here because this is a PyCon event. There is so many ways they implement this in different languages. JavaScript, Java, and the like. But being a PyCon event itself. So there are a lot of options of asynchronous programming in Python. We have async IO. which was introduced to the language in Python 3.4. We've got Twisted, G events, Tornado, Choreo, event rates, and etc. like that. So, but what we're focusing on today is the async IO, which is part of the standard library. It was formerly called TURIP, the TURIP project, but it's been added to the language itself since Python 3.4. So that's what we'll be looking at. So from the doc itself, the Python doc. So what does async IO? What does it do? It's a module, as I said, it's part of the standard library. It provides infrastructure for writing. Let's look at it. Single-threaded, just so your program runs on a single thread. Concurrent code using coroutines, multiplexing IO, accessible sockets, and other resources. Running network clients and server and other related primitives. So this async IO itself that was added to the library itself, so it runs on just one single thread. Most of your program runs on a single thread because multi-threading has its own headache. The code is always complex. You'll have to deal with context switching and all of that. So what async IO itself, it runs on a single thread. It runs on just one single thread, but you can handle concurrent requests, concurrent operation. So, and then you can even use it to implement both clients and servers too for your code. So what are some of the nice things about async IO? It uses an event group, so you don't need to worry about multi-threading. And we know some of the challenges multi-threading has. The code is very difficult to write. And then you have to deal with the global interpreter lock for Python. And then race condition issues, resource starvation. Because if you understand, one reason why codes are slow, in the example I gave earlier, for making calls to an external point, at that point, your computer is not doing anything. It's just waiting for the response. So if you look at it from that angle, so you will have a case that we are not really maximizing and utilizing the full capability and capacity of your computer. So because you're just waiting, your computer is not doing anything, it's just waiting for the response from a network call. So, but the good thing about this, like I said, is so resource starvation. You don't have to just starve your resource at that point while waiting for response from maybe an external server or maybe a database. So it also runs code concurrently, which is just a form of programming, like doing many things at once. Instead of you to be waiting for a response from either a database or an API endpoint, you just keep doing other stuffs. And then it takes advantage of the system resource. So the way it works is in Python 3.5, okay, previously in Python 3.4 when async IO was added, the way it's been implemented is it's been implemented as a decorator, async IO does coroutine, and then you yield form. So where you are expecting network calls, like in that example, I was making call to an external API. So you just yield form in places like that, and then it's just going to continue with other part of the code, and it will be handled in the event group. So, but async await makes it look more readable. It was added in Python 3.5. We are going to see code samples much later and then demo. Of course, it's better than callbacks. For those who have done, okay, I don't want to start a language war here, but for those who have done a language that starts with J, one thing I hate about that language when I was coding it is, okay, I still code it till date. At the point is the issue of callbacks. It's so annoying. It just keeps, I don't know, initially it was really hard for me to wrap my head around. Like, you just keep doing callbacks and then your code is just, though I think the good thing is they've also introduced async await in the language now, so which is something good. It looks like they copied this from Python or maybe C#. So, but yeah, so callbacks is just, I don't know, it's just one hell of a bad thing. Try to avoid it in your code. Even if you still, of course, most of us might still write the J language. So, and the way you just write it is you do async dev the name of your method, and then wherever you'll be waiting for a response, you add an await keyword to it. So that's just the way it works. Async before the name of your method. So it just replaces it from in previous Python. So I'll just show us how some of this will work. We are going to compare codes written in synchronous programming and asynchronous programming that does the same thing. And we're also going to look at the time it takes to execute some of these things. If you have any questions while I'm going, you can just call my attention. So I'll also do a brief demo of this. So if you can't see my screen, or if there's anything you need to call my attention to, maybe if there's a bad code, or if it could be refactored better, you just raise up your hand and just, hey, that's bad code. Yes, that would best be helpful. So I don't know if you have questions on some of the things we've discussed so far.